Thank you. So if I'm saying A2 is giving you 2A, it's a fast reaction. B2 is giving you 2B, is a slow reaction. What is happening in A2? What are you doing with A2? You are breaking the bond. See, you are breaking this bond and is getting converted into 2A. Is this step endothermic, exothermic? Breaking bonds, breaking attractions.
Exothermic. Endothermic.
Endothermic, right?
Endothermic.
Because
Aditi, you are
endothermic has
breaking
high energy.
attractions. Aditi, is endothermic. Is it clear?
Mm-hmm.
Avni and Kyra are right. Endothermic. Let's make the energy profile. Here is the energy. And where should I write A2, Avni? As the reactant here.
Yeah.
Where should I write these two A's?
Should be somewhere
Since,
higher, right?
yeah,
Yes.
since it
Yes,
has
higher.
energy.
Yeah, like this. So write down this. Bond breaking is endothermic. Aditi, bond breaking is endothermic. Oh, Aditi didn't have any notebook.
I can just
It's okay,
take a
Aditi.
screenshot.
No problem. You can watch the video later on and make notes. Bond
Yeah.
breaking is endothermic. You are breaking a bond. Now let's see. We said B2 is very slow reaction. I'm making the energy profile for B2. Here also I'm breaking bond. But see the difference. Children, see the difference. Let's say B2 is here. This is B2. In which case, more energy is needed.
In B2?
In B2, it means B2 has a stronger bond. B2, the bonds are stronger than A2. A stronger bond means more energy needed. Now, can you tell me which reaction is going to take more time? A2 or
The
B2?
B2? B2?
What is the reason?
Because the bonds are
Stronger
stronger, so it
bonds.
takes
In B2
time and more
with
energy to break
in
them.
B2 there's stronger bonds, so it would take more time to break
Yeah,
them.
so can I say that fast and slow has something doing with the energies? A fast reaction, energy needed to break the bonds will be very, very less. Needed is less to carry out the reaction. So that's why it takes place faster. And slow reaction, energy needed is more, so it takes more time to gather the energy, to collect the energy, and then break the bond. Energy needed is high. Can I say that? So basically in kinetics, you're dealing with energies. Kinetics is based on the energy of the molecules. How much energy needed to break the bonds? If the energy needed is very large, reaction will be slow. If the energy needed is very high, reaction is fast. We are clear about it? Now I'm going to teach you another important part of this kinetics. I'm going to clear it. It's called as collision theory. This we are doing in AP chemistry also. But in AP chemistry group, many children are hearing this for the first time. And you are still in the 5th and 6th standard. And as you will see that is a very simple and very important concept. Ready? Okay, keep answering my questions. There is a container. In this container, I'm trying to carry out a reaction. I'm doing the reaction of A2 reacting with B2 giving me 2AB. This is the reaction I'm carrying out. So initially in the container, I added A2. Let's say this is A2. This is, okay. I'm going to make A2 with the green color. So I'm making plenty of A2s. and I'm making B2 with the pink color. This is B2. So tell me the first condition. First condition needed to carry out the reaction. The first condition is that A2 and B2 must collide. If they don't collide, no reaction. We are doing collision theory, right? So
Yeah.
A2 and B2, sorry, A2 and B2 must collide. You're understanding this? If there is no collision, no reaction. Collision is must. So first condition is that they must collide. Okay, now answer this question. If A2 collides with A2, will you get the product?
No.
No.
because A2 and B2 must collide.
A2 and B2 must collide. So this collision is ineffective. Ineffective means it will not give you the product, right? Do you think B2, B2, when they collide, they give you the product?
No.
That is also ineffective. Do you think you can control the collisions? Do you think
No.
that you will go in the container and you will ask A2 to go and collide with B2 only? No, you cannot. So these collisions are random. And in these random collisions, only A2 and B2, when they collide, they can give you the product. But not always. Not always. Only if they have sufficient energy. You remember energy needed to break the bonds? Sufficient energy. If they collide with sufficient energy, then only you will get the product. Is it okay? Okay. Now let's see. Now let's make the energy profile for this reaction. Now tell me, when A2 is reacting with B2, what are you doing first?
You're breaking the bonds first.
Breaking bonds.
Where is Kyra?
I think she had some.
Oh, she
issues.
left.
Came off her video first, and then
Yeah.
she left. Some internet
Like
issues.
some,
Maybe.
I think I heard some like dings, so she probably.
So now both of you are listening carefully. You have to explain this to Kyra. So first thing, you are going to break AA bond, right? This bond. And which other bond?
B and B bond.
And B.
So I'm breaking these bonds. Bond breaking endo exo.
Bond breaking is endo.
Endo.
You are breaking
Endothermic.
attraction. So energy needed to break the bonds.
Yes.
How the profile will go? Here is the energy.
So first it
Energy.
starts
If energy is needed, then it would be
It will be
go
going
high.
like
higher.
this.
Yeah.
Yeah. What is here?
The reactants.
Yeah,
The
A2 plus B2. I'm placing both of them, right?
A2.
So energy needed. Okay,
Yeah.
after that, what is happening? After breaking the
Bonds
bond.
are forming.
So A and B are
Bonds are
making bonds.
Yeah.
They are making bonds. When they make, so bond breaking is endothermic. Bond formation is formation of attraction. So what is bond formation?
Exothermic.
Yeah, write on this. Bond formation, where should I write? Here. Bond formation is exothermic. Why is it exothermic, Avni?
Because nature likes attraction, and when you're forming a bond, it has to do with attraction.
Mm-hmm.
So the two atoms are attracting. So it's exothermic because it's releasing energy.
Can you explain this, Aditi? She's missing one line, only one line. She's missing that line. She said nature likes attraction. Nature likes one more thing, Avni.
Oh,
Nature likes
stability.
everything to be stable.
Stability is related to
Attraction.
And attraction,
And low
which
energy.
is breaking attracts.
yeah, say low energy, right? Stability is low energy. You're dealing with energies right now. 1 second. Okay, I'm back. Sorry. Okay, so you are going to say nature likes stability, low energy. Stability and low energy is related to attraction. More attraction, more stability, more lesser energy. So when bond, what is bond? Bond is a attraction. Attraction between what? Yes, Avni?
Between two atoms.
What can be attracted between two atoms, Avni and Aditi? What is
The
attracted?
Electrons.
The
electrons.
yeah, the electrons of one atom with the electron positive charge of the other. It's a plus minus, right?
Yeah.
So if I place
Yeah.
electrons here, this minus is attracted to this plus,
The plus.
this minus is attracted to this plus. So if somebody asks you, what do you mean by attraction? It's always plus minus. In chemistry, attraction is plus minus. Okay. So bond formation is exothermic. So how it will go down? It will go down energy profile,
Yeah.
decrease
Yeah.
in energy. So I'm going down. Children, I'm going down like this. Let's say it's going down, the green. The green line represents the formation of bond, isn't it?
Mhm.
And what is the blue line representing?
The breaking of bonds.
Breaking.
The breaking of bonds. Kyra, you missed important things. These girls are going to help you. Just start asking question, okay? This is the bond breaking. Bond breaking is endothermic, energy needed. And this is bond formation. Bond formation is exothermic.
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 So can I say during collision, when the, like in this reaction, we were doing this reaction, Kyra. In this reaction, during collision of A2 with B2 to give you the product, minimum this much amount of energy is needed. Minimum this much amount. Because first we have to break the bonds, right? You have to reach on the top of the hill. And if you don't supply this energy, no bond breaking. And if there is no bond breaking, no reaction. What do you think, Aditi? This is the top of the hill.
Yeah, sorry.
If I
was
ask you
on.
to come here, naturally you have to cross it. Only then you can give the product. If you are unable to cross it, no product. So A2 and B2 must collide and must have this much energy, this much. And once they are on the top of the hill, bonds are broken. And then new bonds will start forming and the product is formed. You know, children, what is it called as? Activation energy. Activation. It is activation energy, which you can write like this, EACT. So what is activation energy? Yes, Kyra.
Oh, I have a question. So, what is the ineffective thing on the side?
Yes, girls. Avni, Aditi, help her.
Oh, because when
The
you have
ineffective is
One at a time. So let's give Aditi, you start. You explain this ineffective.
so A2 and A2 cannot like collide because it's A2 and B2 that must collide. So
Hmm.
it's not gonna affect anything because
You will
the
not get the
electrons are
product.
not attracting and you're not gonna get the product.
Mhm. Okay, what Aditi is trying to say that this is the reaction. You see the reaction, Kyra, here?
Yeah,
In this reaction, what is first condition that A2 and B2, they must collide. These must
must
collide,
collide.
right? If this one is colliding with this, do you think you will get the product?
No,
If these two greens are colliding, do you think you will get the product?
no.
So those collisions are called as ineffective. Is it okay? Now, Avni, you're going to explain her this. Understand this also, Kyra. Avni.
So basically, you can only have the reaction when A2 and B2 collide. and so it'll have like, so it'll be the project, and it means that it'll, and when they collide, it'll have sufficient energy to break the bonds and then form them.
Now, can you tell me the meaning of the sufficient energy, girls? Now, I have already
Means you
explained
need
you.
to do the
Means
enough
you
energy
need
to do the
To
more
chemical
activate the
energy
reaction.
to
energy,
break
like the minimum energy
Name it.
required.
Name this energy.
Activation energy.
Yes.
activation.
Yes. The collision must have activation energy or more than that. It can be exactly the activation energy or it can be more than that. Sufficient energy means energy of collision. They are colliding, right? When they are colliding, energy is generated. You know, collisions. When something collides with other thing, energies are transferred. So energy of collision must be equal or greater than activation energy. And if that energy is not achieved, if you are not providing this much amount of energy, then your reactants cannot cross this hill. This hill, children, this one, they cannot cross this hill, and you will not, let's say you supplied only this much energy here, you stopped here. Do you think you will get the products? No.
No.
That collision will be a waste. So the collision, when they have this much amount of energy, this much or more than that, then the product is formed. Are you
I have a
Mhm.
question. So basically, when you say that it has to have that much energy, if it has less, like I'm just thinking of it like a ball like on a hill or something, would
Mhm.
it like fall back down and
Yeah,
have like even less energy like than
yeah,
it used to have?
yeah. She's
Okay.
right. Kyra, Aditi, she picked up an example. This is the hill, and your ball is you threw the ball, but the ball is reaching up to this point. What will happen to the ball? It will come
It'll
down.
Roll
roll
down.
It'll come
down.
It
down.
will roll back. Same here. If they are colliding here, they will come down. Same as such, A to B2. So you can say that collision is again ineffective. Ineffective means will not give you the product. Kyra? So now let's see the example of activation energy. You know, you are using gasoline, petrol. So don't you think that activation energy is needed in every reaction? Because every reaction has to start with bond breaking. Am I right? So in all the reactions, whatever reaction is there, slow, fast, in every reaction, the energy profile is going to be same. Only thing that activation energy in some reactions will be less, in some reactions will be more. Like here, I'm giving you one reaction. This is the reactant here. Now I'm making this here. This is the reactant. Okay, reaction A, reaction B. Can you tell me in which reaction more activation energy is needed?
In B.
B.
In B. So in which reaction most of the collisions, I'm talking about collisions, collisions of the reactant, in which reaction most of the collisions can cross the barrier, energy barrier?
A.
A.
Why?
A.
Why?
Because it
Because
requires
it
less
has
activation energy, which
more
means that
exothermic
every
and
time
bond formation
they
is exothermic.
collide, it
So
creates more energy.
Yeah, Aditi, you're okay with both the
Yeah,
explanation?
sorry, I just
Kyra, your answer was something like that?
yeah, I was like saying about the exothermic and this bond formation is exothermic, then when they collide, it can exceed it.
What is this step, Kyra? This step is exo endo.
Endo.
So that's bond breaking, right?
Mhm.
You're saying exothermic Why?
Like I mean the full reaction is
Full
exothermic.
reaction, yes, that was my next question. She already answered it. The reaction is exothermic, products have less energy, reactants have more energy. So where the energy is going? Out.
Out.
Yes, Avni,
Mhm.
yes.
I have a question about like fast and slow reactions. Like you
Mhm.
were talking about that earlier. So how do you know if it's like a fast or slow reaction? Because like if I'm cooking an omelet or something, like it can be slow, but it can also be fast. So like what defines that?
Okay. Right now, you look at these two energy profiles. Now, according to your understanding, which reaction is faster?
A.
A. So, the reaction in which less energy is needed, they always take place very fast. And the reaction in which the activation energy is very large, you have to supply heat. You have to heat it continuously so that it can get the sufficient amount of energy to cross the barrier. When you're heating needs time, right? It slows
Yeah.
down the reaction. So, which reaction is faster? Write on this. A fast reaction has low activation energy. Agreed?
Yeah.
Fast reaction, low activation energy. Slow reaction,
High activation.
High active,
high
high, ac-
activation energy.
high activation.
Okay, let's pick up two examples. One, you are burning gasoline in your car. You know, you start your car, there is ignition. Why are
Yeah.
you starting the, you know that gasoline is highly combustible. Everybody says, okay, don't put any fire closer to it because it's highly combustible. The rate of reaction is very, very, very high. But still, we need ignition. Why? Ignition, you know, when you plug in the key. So what are you doing? You must have heard from your fathers. He's saying it's ignition, right? Ignition
You're
means you're supplying
starting it?
no, you're supplying activation energy. You are supplying that minimum amount of energy needed to start the combustion of gasoline. Gasoline combustion is also a chemical reaction. Agreed?
Yeah.
Gasoline
Yeah.
on combustion means it's reacting with O2. I'm writing here, children, giving you CO2 and H2O. Gasoline is carbon compound. So for that, you need to break the oxygen bonds. You break the bonds of the carbon, hydrogen in gasoline. So first step is endothermic there also. But reaction is highly exothermic, highly. You can see the difference here? Highly exothermic. So what happens? Initially, I need to ignite the gasoline. Initially, I have to show a matchstick, right? I have to supply some energy to cross this barrier, which we are doing in the cars with the help of that electricity. You are giving an electric spark. Electric spark is also energy. So that's going to start the combustion. Once the combustion started, I need not to provide electric spark again. Why? Because during the reaction, a large amount of energy is released. This is released, right? Now, this is helping us in the combustion of other gasoline molecule. Aditi, you are in the full mood of vacation. Am I right? I think that she's lying, right? She's lying. She's taking the pillow. Am I right, Aditi? That's a good
Yeah.
thing. Okay, no problem. You can enjoy. So, children, is it clear? Avni, Kyra, we are clear about it? So, that's about your kinetics. Chemical kinetics, activation energy, bond breaking, bond formation, collisions. The collisions must have sufficient amount of energy. So, combustion of gasoline is a fast reaction. Can you pick up any other example from your daily life which is very slow? Very slow.
This is like a I don't know. It's like digestion, like when your body digests things and like
Oh dear,
lactic.
that's very fast. Yeah, it takes
Oh,
time, but
it's
not
like
fast,
for
not so fast as
pennies,
gasoline. I agree with you.
for pennies to get like this kind of green color. That's slow.
Uh,
I don't
who
know
is
what it's called.
getting?
Alloy? I don't know what the name is.
Yeah, there are so
First,
many things like growth of your body. Is it fast?
no.
It's taking years, right?
The growth of a tree.
Mm-hmm. The color of? What did you say, Aditi?
Like a growth of a tree.
You could do the color of hair as well, like it becomes white over time, white, gray
Mm-hmm.
over time.
That's aging, you can say, right?
Oh,
So all these are slow processes, but all these are chemical changes. All these are chemical reactions. Okay, so you can pick up many examples. If you can compare combustion of gasoline with making of tea, which one is faster? Combustion of gasoline or making of tea?
Combustion of gasoline.
Yeah. So you can compare any two reactions and somebody will say, why is it so? So what's the answer you're going to give? What is the
Because it's
answer?
exothermic and it releases a lot of energy, and the activation energy is lower.
High.
Oh,
Slow.
high.
For slow reaction, activation energy is high.
Oh, I was talking about the combustion of gasoline, which is really fast.
So that is low activation.
Lower. Low, yeah.
Moving on now, children. Now you've understood the meaning of the race of reaction, and you have understood that in the collision theory, what is the minimum requirement? Activation energy, or more than that. Either the energy should be same as activation energy, or it should be more
Or
than that
greater.
to cross the hill, this hill, right? Okay, now I'm coming on the factors. Factors affecting the rate of reaction. And you will understand the reason also. Rate of reactions. So what is the first condition for a reaction to take place? First condition.
Uh, the
They have
activation
to
needs to be met.
collide.
Say again. The
Activation needs
molecules
to be met.
must,
They need
Oh,
to
break the bonds.
collide.
they must
They need to
collide.
break the bonds.
They must collide.
Collide.
Oh,
If they don't collide, then how is the reaction taking place? No reaction, right? They must collide. Do you think, Avni, without collision, there would be a reaction?
I mean,
Mm-hmm.
no. I mean,
No. So that's the first
you could.
condition.
Yeah, actually, yeah.
It is. Even if I give you one molecule and is undergoing some reaction, there also collision is must. Without collision, no reaction. So let's see the first factor. Concentration. You know the meaning of concentration, children?
Yeah.
Amount.
Amount.
Okay, I'm giving you two pictures here. This is one and this is second. In which case the concentration is high. This is A, this is B.
B,
D.
B.
Yeah, in which case collision rate is high.
B.
B.
If
E.
collision rate
Because
is
they're more
high, more molecules, yeah. And if the collision rate is high, what does it mean?
It means there's more
there's
reaction.
more reactions because
Yes.
there's more
So
forces of attraction.
can I write down this? Concentration high means number of collisions high.
Yeah.
Yeah.
If number of collisions are high, rate of reaction is high. But is this reaction right now, the collision, this concentration, is it changing the energy?
Yeah,
How come?
because there's more
Could you
collisions.
repeat? Could you repeat the question?
My question is, when I have the high concentration, Is it helping you in achieving the activation energy faster? You have to cross
No.
this barrier.
No.
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 Then how come this is increasing the rate? Remember, I was writing effective collisions, ineffective collisions. Remember? Remember
Yeah.
A2 colliding with
A2,
B2, not
Yeah.
effective.
A2,
B2
and
colliding with B2,
B2
not
not
effective. But if A2 is colliding with B2, yes.
effective.
Chain
So if
reaction.
these collisions are
Yeah.
more only, then the rate is faster, isn't it?
Yeah.
So when
Mhm.
you increase the concentration, the probability, this is probability only because we are not controlling it. They are colliding randomly with each other. The probability of this collision is higher. Then you can have more collisions of A2 with B2. And that's how the rate is higher. Avni, is it okay?
Yeah.
Okay, you write on this only, this part. Concentration, number of collisions, rate. Shall I clear this? So concentration is clear?
Yeah.
Okay. Now I'm coming on the next factor, temperature. Temperature, you people are going to explain me. I'm not going to do anything for you for the temperature. I'm going to give you two containers only. There is two containers again, A and B, but this time the concentration is same. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This container is at 20 degrees Celsius. This container is at 50 degrees Celsius. Now, can you tell me which container will have higher rate of the reaction and why?
50 degrees Celsius because there's more
50.
collision because the kinetic energy is increased, so there's more collisions.
Perfect. Very good thinking, Avni. Very good. What she's saying, children? She's saying as you increase the temperature, the kinetic energy increases. As
So the
kinetic
number.
energy, yeah, Aditi,
Oh, so the number of collision increases, therefore the rate increases.
Kyra, you're understanding, dear?
Yeah.
And the rate increases.
Yeah.
One factor she's missing. Anyone? In this, we are missing one factor. What do you think? The collisions will have the same energy, the collisions will be of higher energy at higher temperature.
They'll be at higher
So higher
energies.
energy.
So,
Higher.
high temperature will also help you in achieving the
The
activation energy.
activation
The
rate.
activation
Yeah.
energy.
You're understanding this? So, high temperature increases the number of collisions. Two factors are there. It's a big, big thing. Number of collisions with sufficient energy. Can I say this word? Sufficient energy. Now, more molecules have sufficient energy. It's very difficult to write with the pen here. So please write down sufficient energy. Sometime I'm writing I is making it L. So take care of the spellings. If something is not clear, you can ask. So these two factors are big factors, children. Now, as a chemist, I'm giving you very big information. For every 10 degrees Celsius rise in temperature, rate of reaction doubles. Rate of reaction doubles. Double means the same reaction will take place in half of the time. Like if some reaction is taking 10 seconds, then if you raise the temperature by 10 degrees Celsius, the same reaction will take only 5 seconds. You're understanding this? So can you explain this information which I have just given you, which is generally given to us by the chemist? Chemists are doing chemical reaction all the time. And they informed us that if you raise the temperature of the container by 10 degree, rate doubles. Can you explain how this is going to affect, how it is important to understand in terms of global warming? Why this is
Since
important? Yeah.
So it's easier
because
to have reactions, and that's gonna harm the environment. Like in the
because
environment,
there's more temperature
faster. Like
getting more
Because
hotter,
then,
so there's more
because when there's
Oh.
every 10
reactions
degrees, the
faster.
yes
Faster,
So
yeah.
that's like
and
that's
when the
creating
reaction
like a really big
doubles,
problem.
Yes,
then
yes, yes.
that will.
Everything will for like if every 1 degree rise in temperature is significant, it means that, right? You know how scientists are measuring the global warming? They're measuring the global warming not like this. There is 100 degrees Celsius rise or 50 or 20. No, they say, oh, there is zero point 0.5 degrees Celsius rise in this much years. That zero point 0.5 degrees Celsius rise is very important, very significant because it is going to increase the rate of everything, melting of glaciers, breaking down of the ozone layer, everything increases, right? So all the rate of reaction increases by the increase in temperature. So that is the reason global warming is a very serious issue, right? So are we clear about concentration and temperature? Now I'm taking you on the
Yes.
next one. Next. Next I'm going to say surface area. Surface area. You're going to answer my questions and you will understand this on your own. If I give you a big piece of wood, big piece. Aditi, you are with a big piece of wood and I'm asking you to burn it. And Avni and Kaira, I said, these are the pieces of wood, same amount, in which case the burning will be faster,
The
the
pieces of wood.
Smaller
wood,
amount
the
because there's
smaller
more
amount,
The
because there is more
pieces.
surface area.
there's more surface area.
Why? I cannot see more surface area in this small piece. Like here, this is the big piece, right?
Mhm.
In the big piece, oxygen gas, collision needed. Who is colliding with the wood? O2 gas. So O2 gas can collide from the surface like this only, correct?
Yeah.
But over here,
Yeah,
O2 gas is
but
moving
the gas
in.
can
Yeah,
it's all over the place.
all over the place. It can penetrate inside. In case of Aditi's piece, it cannot penetrate inside. But here, so what happens to the number of collisions?
It
Increases.
increases.
Increases,
Rate of reaction?
increases.
increases.
Perfect. So please write down. Like you must have seen yourself in the movies also, when they are burning letters, they put them into small pieces first, right? And then throw it in the
Yeah.
fire. Yes, Avni, you were raising hand.
Oh no, I just had a no. Never mind. It was I
No, no,
realized it.
speak up. Whatever it was.
The question was that since there are smaller pieces, isn't there more surface area? But then
Yes.
I realized more surface area. It's like
No,
it
you are right.
has to,
Smaller
it's
pieces
that,
have more surface area. Mathematically, it is correct. If I give
yeah.
you a big cube, this you will learn in mathematics. So that's why I was just avoiding it. If there is a big cube, what is
Yeah,
the
there's
surface
less.
area of this cube? 6a
It's
squared.
less. Okay.
6
No,
a
yeah,
No,
squared.
six. Yeah.
like this one is a rectangle square kind of thing.
Like
Square
10
a.
10 squared.
Yeah, so
A.
there are six such. So 6a squared, right? But if
Yeah.
I take out small
Yeah,
cubes out of it, small cubes, you divide
They'll
into.
have more surface area.
that has more surface area.
Yes, yes, that has more surface area. Kyra, you want to say something? Mathematically, there is a proof for it. Maybe your mathematics teacher will teach you. Yes, Kyra, any questions? Okay. Okay, the last catalyst, and this topic is done. Fourth is catalyst. You know the word catalyst? It's very popular word.
Yeah.
Yeah, what is it?
It's basically something that speeds up reactions.
But do you know why? Now you can tell me why if I give you the change in the diagram. A catalyst is used to speed up the reaction, like enzymes. All enzymes are catalyst.
Yeah.
So generally, now the term is used only for increasing the rate of the reaction. Otherwise, they can decrease the rate also. But latest, they are saying that catalyst, we are just identifying it as increasing the rate of reaction. Okay, now you're going to tell me why. Okay, see the effect of a catalyst. There is a reaction A2 reacting with B2, giving you 2AB, and it's with very high activation energy. See here, reaction is very slow, very difficult to carry out. But I added a catalyst in this. Let's say I added a catalyst here in the reaction mixture. So when you add a catalyst lowers the activation energy. Remember that. See? Can you see this line, green line? Let's make it red. This is
Yeah.
this is in the presence of catalyst. Now tell me, which one is faster rate, the red or green?
The red,
Red.
The red,
Why?
because when it
because it
has
has a lower
lower activation
activation
energy, then it will make it more faster.
Why?
because it has a catalyst.
Why? Okay.
Wait,
Then
sorry, you cut out. What did you say?
I said they are saying that the red one has faster rate. I'm asking them why,
because
why?
then
So they are circulating between two words, activation,
then it
energy.
has
Uh-huh.
higher
Because
concentration, higher
there's
number of
more,
collisions, and higher rate
so
of
the rate
reaction.
is
Oh, but activation energy has nothing doing with the concentration. Use some other term, Kyra. What else?
sufficient.
Yes, 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 Aditi. You were
And then
right.
sufficient energy is
Because this can have more
more.
molecules with sufficient
Oh,
amount of energy to cross the barrier, right? So you can say like this, a catalyst. So now let's write down the effect of the catalyst here. What a catalyst can do?
it can lower the activation energy and make
Lowers the
reaction
And
activation
faster.
energy and makes
have
it
more
faster.
sufficient energy.
Lower the activation energy. So more collisions
More.
have sufficient energy, right? More
Yeah.
Yeah.
collisions are with sufficient energy. This word is so important, sufficient energy, very important. If you pick up any big book, college level or high school level, and open this chapter, chemical kinetics, generally it is chapter 13 in all the books. So you will see this sufficient energy written everywhere. And what is sufficient energy? Activation energy or more. Yes, Kyra?
In the book, it said that a catalyst is kind of like a shortcut. So does that mean a shortcut to getting to the product more
Faster.
quickly, or
Yes,
okay?
yes. Hmm. Actually, you know that how it lowers the activation energy? It's not just you add it and it will attack the activation energy. It gives an alternate path to the reaction. So I'm going to discuss about catalyst now, whatever time is left. Shall I erase this, children? Okay.
Yeah.
Like
Oh, yeah, you can.
Kyra is telling me very important thing. You know, when there is a reaction, A2 reacting with B2, giving you 2AB, You are breaking AA bond, you are breaking BB bond, and then new bonds are formed between A and B. This is how the reaction is expected to take place. But somehow, breaking of these bonds need a very large amount of energy. Activation energy is very high, like this. When
Yeah.
I add a catalyst, children, in this, catalyst is a chemical. What this catalyst is going to do? The catalyst will
So
start making new interactions with this AA molecule, with this BB molecule. It is helping. See, this making new interactions means exo, making new interactions.
Yeah.
Attractions, exo,
Making new
exo, right?
exo,
yeah,
yeah.
This energy is then used to break these interactions. Can you see
Which
how
is endo.
catalyst, which is endo, it's like give and
Endo.
take. So catalyst is making new attractions, energy released. That energy is used in breaking the attractions of A2 and B2. So generally we are learning it as an alternate path. Is providing an alternate path.
So first you break the attractions and then you bond.
Mm-hmm. With minimum
With the
energy.
cat.
Yeah, now Aditi is forcing me to teach you one more thing. The way Kyra said, and I gave you this word alternate path with minimum energy. Now Aditi is talking about, then after that, what happens? Now B is broken, B is out. Now this B is bonded to catalyst.
Bonding. Yeah.
This A is bonded and this A is out. Now
mm-hmm.
these two are free to combine. And similarly, when they combine, energy releases, then this break, then they will combine. So what happens to catalyst?
It doesn't get
Catalyst. It
consumed. It's not
does.
consumed.
Yeah, it is not consumed. It's regenerated after the reaction. You cannot say it's not participating. Some teachers they use this word. Oh, catalyst doesn't participate in the reaction. No, no, very much. It's participating. It's changing the entire mechanism. It's changing the entire path of the reaction. But after the reaction, regenerated. Is it okay? After the
Yeah.
reaction, the catalyst is regenerated. For example, CH2
Yeah.
double bond. I'm just giving you one example, children, maybe not of your level, but just think like a reaction. And here I'm adding a catalyst. If I don't add this catalyst, this reaction will not take place. Will not at all. So, like in college chemistry, children are learning. Oh, I need a platinum here or palladium, nickel. It gives you CH3, CH3. So, what is PT here? Is the catalyst.
The catalyst.
It will participate and it is regenerated back as such. No change. Is it okay? So,
Yeah.
are we done with this part? Very important thing.
Yeah.
One
Mm-hmm.
second.
Yeah.
I think I told you these graphs also, the one here, this one. See, you can see the activation energy graph over here
Mm-hmm. Or
with
without
catalyst and without
catalyst. With,
catalyst. Yeah. These are
yeah.
very popular question. Enzymes are catalyst, children. Enzymes in our body, biological system, all those are biocatalyst. Enzymes that you must know. Somebody can ask you. Okay. So we'll continue in the next class then. See you then. Bye bye.
Yeah. Sure.
Bye.
Bye.
Aditi, enjoy yourself.
Bye.
Bye bye.
Thank you. Bye. Have a great day.
Thank you.